Hello students, welcome back. In our last video, we did some pretty amazing work with Polarity. We created our gameplay world and our player, and we had this simulation of movement, right? Our world was moving, and it made it look like our player was infinitely running across the screen. It was really cool. And in this video, we're going to do some really cool stuff again, but this time, the work that we are going to do is going to be more on the back end of our game. See, our game is going to need to understand the current state that it is in. So some states that our game might be in are a start state, right? We just loaded up the game and maybe we want to show, instead of showing like our gameplay world and our player, we want to show a start screen. And then when the user presses enter, maybe to begin, we want to transition from that start state, no longer show the start screen. We're going to swap that screen out and then show our gameplay world and our player. And we would be in a play state. And we'll play our game and we'll play our game, but eventually we're going to die. And so we would lose the game. And that would require another state change, going from the play state to a lose state. And there, we would swap out our gameplay world and show a game over screen. And so in this video, we're going to learn how to manage these different game states and give our program the logic and understanding it needs to be able to transition from one state to another. And we'll also talk about creating those start screens and game over screens, which have a special name here. We call those overlays, because they sit over our game world. So let's head to the computer screen and we will dive right in. So I have lesson 2's starter file open here in vscode.dev. I'm going to minimize my browser and open that file directly. So if I come over here, I'll open my Polarity folder and we'll go to lesson 2 and open lesson 2's starter file. And so when we do that, boom, we are thrown right into the game, right? This is exactly where we left off. No start screen, right? I would love to have a start screen instead, and then we could go through and start playing our game. So we've got a bit of work that we've got to do here in lesson 2 for Polarity. So let's head down to our mission checklist and let's look at mission number 1. It says we need to add the game state values. So basically we are adding a new system to our game, a state system, something that can manage whether we're in the start state, the play state, or the lose state. And so anytime we add a new system to our game, we typically start by adding a constants for the game, things that we could tune, and those appear in our student edit zone. So I don't even need to search for this. I'm just going to go right down here and look at this. Mission number 1, our game state values. We are going to add the game state values here for a start, play, and lose state. And we're going to use clear names so we can easily switch between our modes of operations. So I'm creating a constant variable here called game mode. Now, game mode is an object. Objects have curly brackets, right? Just like our player object has curly brackets. And objects have properties, right? You set the property name and then you give it a value. Property name, give it a value. Property name, give it a value. We are going to do the exact same thing here for our game mode object. Our properties are going to be the different states that we can play in. So I'm going to use all capital letters here, so it's very clear that these are game states for me. So I'm going to create a start property, and then I'll put a colon, and then I want its value to be a string of the word start. So now that object has one property, start. But I'm going to create another property. I'll call it play, and I'll give it a value of the string play. So now we have 2 properties. And then I'll create a third property because I'm going to have 3 game modes. We'll may have a lose mode or a lose state, and the value will be the string lose. Awesome. Now, you could expand this if you want to. After you build this game out and you want to add more to it, you could create a pause state. You could create a menu state. You could keep building this functionality out because once we make this system and the system works, it's easy to expand. But for right now, we are only going to have 3 states. We'll have start, play, and lose because those are easy for us to manage. Now, this is a constant. Which means this is never going to change once we define it. But if you think about it, we probably need a variable that is not a constant, a variable that can change, right? It can change from the start state to the play state, to the lose state, back to the play state. If we reset our game, back to the start state. We need something that we can use to switch or manage our game states. And so that is where mission number 2 is going to come into play. So let's go to mission number 2. Mission number 2 is all about getting our starting game mode. So we want to set the current game mode to the title screen and make the game begin in its correct state. So it looks like we have a new variable here called current game mode. And this is right here outside of the student edit zone in our gameplay variables section, where we define all of the variables that our game is going to use. And so we are declaring this with let, which means, hey, we can change the value of this variable. Current game mode can change. It could be the start mode, it could be the play mode, it could be the lose mode. Well, right now it is set to null. And null is just a way to say, it's set to nothing, right? Null is like an empty data. It's just nothing. So we don't want that to happen. So when we start our game, we want our current game mode to be start. So how do we get this start state? Well, we go to the object that we just created. That object that we just created is called game mode, and it stores all of the possible states our game could be in. So we are going to use our game mode object and access one of its 3 properties. So right here, we'll take our variable current game mode and we'll assign it a value equal to the game mode object. So game mode, tab to autocomplete. So nice, right? You just start typing game and then, well, you got to be careful. You don't want game font, so you got to find the right one from the list. Game mode, tab to autocomplete, and then a dot to access all of its properties. And if you look, we have a lose property, a play property, and a start property. And when we start the game, I think we want to be in our start mode. So we're going to set it equal to our start property. Awesome. So now when we refresh our game, right now, boom, our game knows what state it is in. It knows that it is in the start state. It's just that we are not doing anything with that information. Our game is knowledgeable, but it's not using that knowledge yet. So let's go to mission number 3, because what I would really love to do with that knowledge is show a start screen. And that's where mission 3 brings us. It finds us in a function called draw start overlay. All right, so this is like down here, down at the bottom of our code with all of our other draw functions, right? We got draw background, here's draw player, here's draw HUD, and now we are going to draw our start overlay. Well, let's look at what we're doing here in this draw start overlay function first. So the first thing that we do is we say, no stroke. That means give me a marker that is invisible so you do not see the outline of the shape that I'm about to draw. And then we put some paint in our paint bucket. So we say, hey, let's fill our paint bucket with overlay BG color. Ooh, if you look at this, this is probably a new color that is in our color palette. Let's go check it out. I'm going to just jump up here to my color palette. Bloop. And if I scroll down, yep, I have a new color in my color palette, overlay background color. And if you look, it is not a hexadecimal string like all of our standard colors. Instead, this is called an RGBA string. RGB stands for red, blue, green. Red, green, blue, and the A stands for alpha. Alpha is a way to set a transparency of a color. So anytime I want a transparent color or a color I can sort of see behind, I use an RGB alpha string. And when you do that, instead of using hexadecimal numbers 00 to FF, you use decimal numbers. So 0 is none of the red, and all of the red would be 255. You do that for the red channel, the green channel, and the blue channel, but your alpha channel is different. Your alpha channel here goes from 0 to 1. An alpha of 1 means you cannot see behind the color at all. It's not transparent. An alpha of 0 means you're not going to see the color at all. You're just going to see behind it. It is fully transparent. And setting something like 0.65 means it's going to be slightly transparent. You're going to be able to see behind this color just a little bit. And that's exactly what we want for an overlay. Because if you look, once we fill that paint bucket, we draw a rectangle. And our rectangle starts at the coordinate 0, 0, so the upper left-hand coordinate of our screen. And then we go the whole width of our canvas and the whole height of our canvas. So we're going to start here and we're going to draw a rectangle that sits on top of the game world, and we're going to be able to see behind it. That rectangle will be our start overlay. So our start screen is going to sit on top of the game world, and we should be able to see slightly behind it. So what is our start screen going to say? Well, mission number 3 says we got to draw the start screen and show the title over the game board. Okay, so it looks like we already got some text here. It looks like we've got text size is 18, so that's sort of small, but that's all right. And then we've got flip polarity, WS, or up down, maintain stability, or suffer polarity collapse. Press enter to start. So I'd say this is like flavor text, right? This is text that kind of gives the user a little bit idea what they should do and builds the lore or the story of our game. And if you notice here, each of these texts we are putting at a horizontal position of width over 2. So that's smack dab in the middle of our screen. And then for the vertical positions, this is a vertical position of 0. This is a vertical position of height. And so what we're doing is we're taking the height variable and multiplying it by decimal values to position it somewhere between 0 and our height. So that system is going to work really nice. I just think we need to show our title, right? And we have never set any properties of our text. Like if you look right now, we've got the background color, our black, as the paint in our paint bucket. So when I make these texts, they're going to be that transparent black. You're never going to see it. So the first thing we got to do is we got to set some properties for our text. Let's put a new paint in our paint bucket. We're going to put in text color. All right. We had seen that. I think this is white. Yeah, this is just a nice white here. And then I'm going to say, how am I going to align my text? So I'll do text align, and I will do center alignment again. Center and center. And then this is going to be for my title. I want it to say polarity. So I want the text size to be bigger here. So we'll say set a text size of 60. And now that I've got that all set, let's make our text. So we'll call the text function. I'll put in a string polarity. The X position is going to be the width of my canvas divided by 2. And the Y position, we're going to mimic what we were doing here. I want this to sit on top of all of this. So the decimal that I'm going to multiply is going to be smaller than 0.44. Let's do height times 0.3. I think that could work nicely here. All right. So I think mission 3 is done. So let's see. Is our start screen going to show up? No, rats. Well, we defined our data, right? But I don't know, we might not be calling this function at all. Just because you write a function doesn't mean it's automatically going to happen. You still have to call that function. So let's see if mission 4 brings us to that. So I'm going to search mission number 4. Well, it doesn't look like it. Mission number 4 has us doing some more work on this overlay system because, yeah, we are going to show a start screen. So we have draw start overlay, but we're also going to show a lose screen. So we have draw lose overlay. And if we look, we do the exact same thing as we did in a draw start overlay. We get an invisible marker so we don't see the outline of the shape we're going to draw. We put a transparent black color in our paint bucket, and we draw a rectangle that sits over our entire screen. Then we set our text properties and we show polarity collapse. That's our way of saying game over. And then we have some flavor text. The magnetic field has fractured. So now we got to put some more flavor text here. It says draw the lose screen overlay and show the restart instructions. Yeah, so we want to get the player to play again, right? We don't want them to just play once and then give up. So let's put some new text here. So we'll say text, and I'll put some flavor text. I'll say press enter to re-stabilize. I like how that sounds. Stabilize. So we want to restabilize our field so that we can get back in the game. And we're going to position that text at width over 2. And our height, I'm going to push it down. So we want it to sit below this. So instead of being height times 0.44, we're going to use a bigger decimal. So I'll do height times 0.55. And that's if they want to play again, but we'll also give them the option to just go back to the title screen. So I'll say text, press R for the title screen. So we'll give them that option, right? They say, I don't want to play anymore, but we'll just leave this up. Maybe somebody else will come by and want to play polarity. So we'll press R. So width divided by 2, and this will sit below that. So we'll do height times 0.66. Very good. Only problem, we're still in the same boat. we've written those functions, but I don't think we're calling draw lose overlay or draw start overlay at all. So we got to call these functions. Like, I actually want to see these screens appearing. So let's go to mission number 5. Mission number 5 says show the correct overlay for the current game state. Yeah, see, we're not showing our overlays. So that's what mission 5 is going to need us to fix. So let's head to see where this puts us. All right, it puts us in our draw scene function. So remember, draw scene is happening every single frame of the game because this function is getting called from inside our default P5 functions. So we have 2 of them, setup and draw. Setup runs once, boop, when you load your game or restart your game, and draw runs every single frame of the game. And every single frame of the game, we are calling draw scene. So now we know that this is happening every frame. We just got to draw our overlays. So why don't, I mean, I got the function. Let's just call it. Let's call draw start overlay. And now if you just write the name of the function, it's not going to get called. To call it, you need the name. And then these 2 little parentheses mean call that function. Run those lines of code. And then I'll put a semicolon. Hey, with that, this function gets called every frame. We are now calling draw start overlay. We should see our overlay. Hey, that is awesome. Look at how cool that is. That's a great start screen. Polarity. Flip the polarity. Maintain stability. Press enter to start. So that's looking pretty good. And you can see we got that nice transparent black so I can still see behind and see the game world. So I really like that. Well, we've got 2 overlays, so why don't we just call the other one too? Let's do draw lose overlay, and we'll call draw lose overlay. I did a nice little tab for autocomplete right there. So let's refresh the page. Now we should see, both of our. Well, I guess we do see both of our overlays. It's not really what I wanted though. If we look, it's like we're drawing our game world. Then we're drawing our start overlay, and then over that we're drawing our lose overlay. That's not right. We don't want to draw our start overlay and our lose overlay every single frame of the game. We only want to draw them if the game is in the start mode or if the game is in our lose mode. So we actually have to ask some questions here. And the way we ask questions is using an if statement. So we're going to type the word if, and then we're going to put parentheses, and a question is going to go in here. And based on the answer to the question, if that question answers yes or true, we are going to run a line of code that we put over here. I'm going to say draw start overlay. All right, so what question do we want to ask here? If this question is true, then we want to draw our start overlay. Well, we want to check to see if the current game mode is equal to the start mode. Remember, we have 3 modes of operation: start, play, and lose. We only want to draw the start overlay if we are in the start state. So let's ask that question. We had a variable we created in mission number 2 called current game mode. And we're going to check to see if it is equal to start. The way we check for equality is with 3 equal signs. 1 equal sign assigns a value. 2 checks for loose equality. 3 checks for strict equality, which is exactly what we want because we're going to see if this is exactly equal to our game mode object. So game underscore mode. Remember, we defined that in mission number 1, and we're going to go to its start property. If that is true, right? If this answers yes, then we'll run this line of code. And only if this answers yes. Yes is essentially a Boolean value of true. So let's run this. Hey, look at that. We got our start screen. Now, let's go mess with current game mode. I think that was in mission number 2. So I'm going to go to mission 2. Yeah, see, mission number 2, we set this. So it's currently set to start, so it works. What if we set it to play? If we set it to play, now it shouldn't work. All right, perfect. So it doesn't work. What if we set it to lose? Okay, so it doesn't show the start screen. But if we set it to lose, I would really like to show the lose screen. So let's come back up here and let's go to mission 5 and let's ask another question. Let's say if current game mode is equal to 3 equal signs for strict equality check, game mode dot lose. So if that's the case, if that answer is yes, we are going to draw the lose overlay. Tab for autocomplete, 2 parentheses to call it. So now we know the current game mode is lose. So this question, the answer is no. So we don't run this code. But the answer to this question is yes. So we're going to run this line of code. And we should see our lose screen. And there it is, polarity, collapse. Awesome. So this is working out perfect. This is working out perfect. Now, there's just one small thing here. We're going to change this just slightly. Right now, we're asking two separate questions, right? We have a question here and a question here. If our current game mode is start, we run this code. But then we're still asking this question. If we know the game mode is start, there's no way it's going to be equal to lose. So we don't have to ask two questions. We only have to ask this question if this question was not true. So the way we do that is write else if here. So now putting if and then else if, we've sort of linked these two questions together. If this is true, do this and then stop. If this is not true, let's ask this follow-up question. And if that's true, then we'll do this. All right, so that mission is all set. You know what? Let's go back up to mission number 2, though. Let's change it to back to start, because we don't want to start our game in the lose state, right? As soon as we play our game, it's just like, boom, you lost the game. That's no good. So let's put this variable back to start. And now we're nice game developers. So when someone plays our game, they start at the start mode instead of just automatically losing the game. All right, so mission 5 is done. Let's go see what mission 6 has us do. Mission 6 says in the draw function. So this is the P5 draw function. It runs every frame of our game. So if we're at 60 frames per second, it's going to run 60 times every second. And what are we doing? Well, right now, it says only update movement during play mode. Stop the game actions while the overlays are showing. Yeah, so if you look like right now, I got the start screen showing, but it looks like my player is running because our world is scrolling. And I don't like that effect. Well, the start screen is present. I just want the game to be still and not operational. And only once the user has entered to transition into the play state should the game become active. Well, let's look what's happening. We are updating our world here in our draw function, and that's where we move those vertical bars. And we're asking a question. We're saying if true. Well, if you ask a question and the question is true, true will always evaluate to yes. So this code is always running. We're always updating our world. That's not what we want to have happen. We need to ask a question that is sometimes yes and is sometimes no. And the question that we want to see, is the game currently in the play state? If the game is currently in the play state, if that answer is yes, then we'll update our world. But if it's not in the play state, we won't update our world. We won't run this block of code, and we'll just simply draw our scene. Now, why is this inside curly brackets? Well, if you want to do more than one thing, right? If I had another line of code here, I don't know, like update player, right? If I wanted to run another function, instead of having it inline, you would have to have curly brackets. And we're definitely going to do a lot of stuff in here, so those curly brackets are there for us. So let's ask our question. We want to ask, what is the current game state? And if it's equal to the play mode, then we're going to update our world. So current game mode, that's keeping track of the current game mode. 3 equal signs to check for strict equality. Is it equal to the game mode object's play properties? I'm going to go right there, hit tab for autocomplete. So now if that question answers yes, then we update our world. We'll move the world. But if it answers no, we're not going to. All we're going to do here is draw our scene. Let's check it out. Hopefully those lines stop moving. Perfect. So now we have a static start screen. Exactly what we want. So now I have to press enter to start my game. So when I press enter here, I want to transition into the play state. I want to start playing the game. But right now I am spamming the enter key with 0 results. Nothing here is happening. What an absolute bummer. Well, we just got to go to mission number 7 to take a look at this. Mission number 7 is all about the start transition. So you want to start the game when enter is pressed and switch from the title or lose screen into our play mode. Okay, so where are we? Well, this is in a new function called key pressed. Where does this function live? Well, if I scroll up a little bit, it's right next to draw and next to setup. These are some built-in P5 game loop functions. So key pressed is from P5. So it's that P5 library that we brought in. So let's just review this. Setup runs once when we refresh our game or restart our game. Draw runs every single frame of our game. And key pressed runs anytime a keyboard button is pressed on the computer. So if I press the P key, this function runs. If I press the H key, this function runs. If I press the Enter key, this function runs. If I hold down a key, this function does not run. It only triggers when the key is being pressed. So let's look at what we're doing in this function. Anytime we press a key, we get the key code that is a part of that key. So every key on our keyboard has a special key code. So the first thing I do is I ask a question. So a key was pressed, and I ask a question. What is the key code of that key? If key code is equal to enter, and then the enter key is a special key, so we can just use enter here. So if it's equal to enter, what do? Well, we want to run some code, and it looks like I ask a follow-up question. So I have a question inside of a question, and these are known as nested if statements. So, hey, a key was pressed, so this function runs automatically. The first thing we do is we ask a question. Was that key the enter key? And if the answer to that question is yes, we ask a follow-up question. Is the current game mode equal to start? These two vertical bars mean or. So is the current game mode equal to start, or is the current game mode equal to lose? When you ask a question using or, is the game mode start or is the game mode lose? Only one of those things has to be true, right? So if the game mode is start, this is whole question answers yes. If the game mode is lose, this whole question answers yes. If it's neither start nor lose, like if it was the play state, then this question answers no. So we're only going to transition into the play state if we are not currently in the play state. So how do we transition into the play state? Well, we're just going to do current game mode equals game mode. Go to my game mode object, hit tab for autocomplete, and we're going to access its play property this time. All right, so now we should be able to hit enter and transition. So let's see. I'll refresh the page. I'll press enter. Ooh, look at that. We were able to transition. Now, I'm going to let you in on a little secret. If we look over here, we should be able to transition into our lose state. If I scroll down, key pressed, we can check for a variety of keys. Right here, we're checking for the enter key. But if I scroll down a little bit, I have built in a debug system for us because right now we don't have a way to lose the game. But if we press a key, and if that key is equal to G, we are going to force a game over. We're saying, hey, if the current game mode is, or if we press G, then we have a follow-up question. If the current game mode is play, we're going to change the game mode to lose. And when that happens, we should show our lose overlay. So let's test this out. I'm going to hit G for game over. Hey, polarity collapse. So now when I press enter to restabilize, I should go back into the play state. And I do. Game over, play, game over, play, game over, play. Now, one thing that I'm going to note here is that when I hit game over, see where the lines are? The lines pick up in the exact spot where we left them for our new game. It's like we're not actually resetting them. So when I come back here to mission 7, when we set the game mode to play, I should probably reset those lines. And right now, it's not that important because it's just lines. They're just visual. But there's going to be other values that we might need to reset when we go into the play mode, when we're going to start playing a new game. So before I transition into the play state, let's call a function reset game to defaults, tab for autocomplete. And remember, this function lives right here. And so we're going to fill this function in, resetting all of our systems. Right now, I only really have sort of like one system, like our world movement system. So we just got to reset that. So now if we run our game, I'll play game over. And now if I hit enter, our lines go back to exactly where they are. So that's working really great. So that line is going to get shifted as soon as I hit enter, and it does. Perfect. Very, very good. Hey, we're almost done here. Mission 8's the last thing we need, and this is part of our key pressed function. Mission 8 says we got to be able to go back to our title screen. So we want to return to the title screen with the R button. Reset the game and switch back to start mode. So right here it says if false. So we're asking a question, but false is always going to answer no when we ask a question. So if this is always answering no, this block of code is never, ever, ever going to run. That's a bummer because I want to be able to like hit the R button. If I get a game over right here, it says press R for the title screen. I want to go back to the title screen. So we got to ask a question that is sometimes yes, sometimes no. And what is that question going to be? Well, let's mimic what we did down here for our lose screen. I'm going to check to see if the key that was pressed is equal to R or, so 2 vertical bars, or, and then I'm going to check to see if that key was equal to capital R. That way, if their caps lock is on, we'll be able to still reset the game. And if that is true, look at what we're doing. We're resetting our game to default. So that's super important for us. Before we start playing again, we got to make sure we reset our game. And then we're setting our game mode to start. So we should then see the start overlay. I think our game state system is complete. Let's test it all in its entirety. So here we are. We're in the play state. Nothing is happening in terms of movement. So if I hit enter here, I see the start screen, our start overlay. I'll hit enter and we transition into the play state. So now the game is active. Our world is moving. Perfect. I'm going to hit G to force the lose state. So we're going to force a game over. And when I move into the lose state, I see the lose overlay. Awesome. Our game stops again. And now if I want to go back into the play state, I hit enter and I'm back into the play state. Excellent. I hit G, I transition into the lose state. If I hit R, I should go right to the start state. So I should see the start screen. And there it is. We're back into the start state. If I hit enter, I can go back into the play state. And then I say, all right, I'm tired of playing. I'm going to walk away from this, but let's leave the game on. Maybe someone wants to play it. I hit R and we go back to our starting screen. All right, so this system is fully operational. This is all back-end work. Our game now has the logic and the understanding of what state we are in, and it can swap out our screens. It can show us our start overlay, our game screen, or our lose overlay, depending on the state of the game that we are currently in. And this system can be expanded. So maybe at the end of these videos, you might sit there and say, I'd really like a pause screen so I can pause my game. You just make a pause state and a pause overlay and map a button press on your keyboard for that pause screen. The system works, and when it works, it makes things simple. So with that, we'll end here, and I'll see you in the next video.